is first off, let us see. Do this is going to be share the screen briefly. Okay, I don't see what happened. Go back to my other file, right? Okay, you see I have here. Okay, and then this is what I'm gonna do is I have yes. So let's go back over here. I don't think it really matters that much. Okay, let's get it done quickly. Sure. Okay. Okay, let's share this screen. Let me approach what I'm currently working on. Okay. So if you see, this is the issue right now. Currently working on it's delayed. No. Let me check briefly what exactly the issue is. Okay, so evict. No, this is not the evict issue. This is starting node refresh. Yes. Okay, so I already have a find recently. So find the most recent function. And what is going on is that I iterate over every single bucket of my every single node of my bucket, and I will find the smallest node ID and return that, which is going to be used later when the bucket gets filled up. I will evict that smallest node ID. Okay, and what I need to do now is actually perform the eviction. I think I already did that actually. So there should be a remove function somewhere. And right here, I have a remove. And what else is missing is the evict the least recently seen node, right? Adding a new node. Modify the add check, right? Okay. Replace the evicted node with the new node. So that's what I'm going to do here. Okay, it's not big around. Focused. Is that? Yes. Sure. I evicted it. Okay, let me check. Self recently. Yes, awaited. Okay, sure. I removed it and I pushed a new entry. So just making way. Okay. Let me do. So I was stuck on the actual task. Was it? No, I was spawning I was spawning a handle, right? And then have not a loop because I have to lock to access this respective bucket because it's behind the read write lock. Okay, so I think let us remove that, and we will need to do what exactly? So this is going to sleep every so often. We can see here that where is the sleep value? Okay. I'm gonna error handle, task cancel. Okay, sleep. No. Let me check. Right now, I'm looking at the examples of how to do this correctly. Task handle allows you to await the result of the task or check if it's completed, right? Check if it's completed. Yes, sure. Okay, and then we awaited that result. Sure, we still awaited. Simulate some work that might fail. Okay, so mostly we have to await this handle. I'm not sure who's gonna start. It's fine. Okay, so say I do something like sleep. Let's say. So I spawn the task, and then maybe there's like a timer. Let's see. There must be a way to do this. Tokyo timer interval run function. Yeah, currently just searching, I think, how to do this correctly. Interval. Okay, wait for the next tick. And I remember there was actually a tick issue. Tokyo tick issues with this. So, oh yeah, drift over time. Okay, so consistently. A fixed delay without strict periodicity. What does that mean? Concurrent access, shutdown, and cancellation. Mechanism to break. Yes. So high precision timing is what is going on. You might need to adjust the interval or consider alternative approaches, but note that high precision, I mean, must. Okay, a timer wheel, yeah, sure. Tokyo. Ensure that your task consistently completes within the interval duration. So you're using timer right. Tokyo time sleep. Don't get difference here. Okay. Of repeated tasks. Okay. Regardless of how long it takes. That's true because it's asynchronous task. Okay. Takes longer. We'll skip to a line. Sure. Okay, makes sense. Sleep is enforced. Right. There's no drift. Takes 3 seconds. Okay, so let's say I sleep for 3 seconds. The next sleep will start after that. And the function will run at 5 seconds, 10 seconds. What's going on? Okay, start at 3 seconds. And then I go to 5 seconds, sure. And then how did I go to 10 seconds? That's what I'm talking about. So run at 5 seconds, 3 seconds. Sleep. Okay. Let's see. 2 seconds takes 3 seconds. We'll skip 1 cycle. Yeah, sure. Next tick we'll skip 1 cycle. Here if my function takes 3 seconds, the next tick will skip 1 cycle, and the function will run at 4 seconds. Let's see. Skip 1 cycle, so it takes 3 seconds to run. Okay, so interval, right? Because and the function will run at 4, 6, 8. Don't quite get. Okay, don't quite get it. Okay, whenever I'm stuck, just ask for more help. I think that's more useful. Okay, let's check the time. Okay, let's keep it moving. Okay, interval. You're asking Tokyo to schedule ticks every 2 seconds. Okay. Yes. Okay, every 2 seconds. Right. So what is going on here is these are two. Okay, same task. This runs in the back. Yeah, 2 tasks. Okay. Interval would then wait for the next scheduled tick. Sure. 3 seconds. 4 seconds. Visualize. Yep. Visualize is more helpful. Okay. This reminds me of the debounce thing. That was that. Debounce. Yeah. Without the actual visual, it's really hard to understand what is going on. So, it's not around. 441. Fuck it up. Okay. 1. Oh, that's interesting. So it takes 3 seconds to execute. 0. Okay. 0 wants to tick every 2 seconds. And then starts at time 3. Okay. 4 to 6. Sure. Since next tick should have been time 2, it is skipped. Okay. task 2 immediately after task 1. Okay, come on. Next tick should have been at time 2. It is skipped. Task 2 starts immediately after task 1. So is that what starts off the new task? So interval, and then we start off a new function. But it took 3 seconds. And then, okay, sure. Okay, so it says, we guarantee to sleep at least. So they kind of overlap. Starts at 0, and then let me get, okay. So this one we started off first, 2 seconds. How are we gonna do this? So 3 seconds, and then sleep 2 seconds. Yeah. So I think okay. Add when concrete, when to use. Use either. Okay. Fix schedule task. Sure. Yes. Heartbeats. Simple delays. What's going on? Using full fix interval. That's how long the task takes. This is confusing. Consistent schedule, even if it means okay, even if it means skipping intervals, if tasks take too long. It doesn't matter more than exact delay between them. So I'm not too sure actually. I'm sure about the delay consistency. Fixed delay. 3 seconds. So if it takes a long time, I would want to do it really quickly. Yeah, I think maybe this makes more sense. Heartbeat. Yeah. Okay. Should copy that down. Let me mark that down. Sure. Okay, and put that. Save timing versus interval. Sure. Okay, and then let me put Tokyo time. Yeah, that's a period I got rid of. Tokyo. So I want to do sleep versus interval. Right, sleep versus interval. Sure, interval. Okay, interval. And in this case, okay, and what I will include is full tick await. So let me just mark this down because loop. Okay, interval imported. No, I think that should be automatic. I guess not. Right, and then so what I can do here is, since I already passed that into the function, I can add that right here. And so, but start node refresh. Let us think what this was supposed to do in the first place. Start node refresh is going to be okay, updating the last scene periodically pings. Okay, updated time. Okay, sure, update the time. Fine. Often I want to update time, update nodes, last scene, update last scene. Okay, and then say I can pass in the last scene, sure. Not the refresh interval, but give me a vector of node references, sure. And then nodes, I want to do, okay. I think it should be fine, right? No entry, something that's seen is immutable, right? So I'm not sure. It's okay. Wait, what's going on? Okay. Update last scene, sure. Background node refresh. No, it's update periodic refresh or update last scene. Okay. updating. Let's add that comment. Okay. So what I want to do here after I locked it, what I want to do now is, so my interval is ticking. Every so often, I want to call my update last seen function. Good. With what exactly? So that will start a job. Okay. How about let's just like comment this out, and then I'm going to do here. Yeah. So just move the code over here. Update with my handle. Yeah. Read. Okay. Interesting. What's going on? I need to from the buckets. You can see the definition. After I locked it, now I have a vector of buckets. Sure. And then vector of buckets. Right. Buckets. Nodes. Actually, where's nodes? Should this be in routing table or should this be in buckets? No, it's in routing buckets. Interesting. That's fine. That value equals to take the reference buckets. Let's see what happens. Wait, why is it? What's going on? Buckets here. Read await. Yep. It's going to be, so I locked it. Yep. So what's going on here? Not too sure. Let me see. Spawn. So yeah. Let me see. Spawn. Maybe that's why I'm no confused on actually. Okay, so that's what the function I want to repeat on interval basis. This would be considered like a ping heartbeat kind of functionality. Why is that? Because you see, these intervals, because I have a fixed interval this task takes. So whether or not I adding or adding a takes extended period of time. Implementing a heartbeat mechanism. Signal must be sent, or a signal must be sent to a server every 2 seconds. Sure. Okay. And signal, you might want a system catch up as close as possible. Sure. Because that would mean that the routing table is larger, so I want to update more frequently. Okay. Okay, as long as you can justify, I think it's fine. Okay, and trade-off. So maybe I didn't want to, but justify, I didn't want to update it, right? Maybe it takes a long time, maybe it consumes a lot of resources. In that case, I think it's just one asynchronous call. Though it takes longer to return, that means that in the frequency of the updates, if I collect the metrics, would inform me on whether or not it was not turbulence, but fluctuating. The churn, if there was churn in the network, okay. Churn in the network, implement a method in routing table. How are we going to do this using Tokyo? So I'm still trying to access my buckets. Sure. Okay. This is getting a little confusing. Comment that all out. Okay. Yeah. So what if I do that? And then reference. Right, I cannot over the value. Yes. So by in my vec node vec, sure, node vecs vec references, node refs. Okay, node refs. Okay, good. Node refs. In what I can do now is, since okay, what I need to do now is declare the iterator. Most likely you need a iter mute and then enumerate. Yep, enumerate. Fine. Okay, this is behind the mutable reference. Sure. Update it. Right. Let me put it. Is modified, but is not implemented. What's going on? Let me see. Right. Deref mute has been implemented. Oh, can I borrow bucket that's mutable? Sure. Okay, so now I want to explicitly say that I'm going to mute this. Okay, iter mute, and now I can assign my node. Sure. Why is it? So explain this. Let me let me update it first. So you can see my value is a bucket and what values I have precisely. So for nodes, I assume I can iterate over the nodes, right? For nodes in node entry. Okay, nodes, sure. Nodes, okay. Node in nodes. Did I implement the iterator? I'm not sure. Okay. No, I don't think so. Well, somebody to iterator. Okay. How can I implement it for buckets? Bucket. Let's go back to the definition of bucket, right? Okay, so here I have vector of my node entry, and then what I need to do right now is have some kind of vector over the node entry. Let's expand this. Okay, over the node IDs, the iterator of my vector. No, actually, why I need to do that? I'm not quite following what exactly is going on. Nodes lock. Oh wait, did I wait? Well, maybe that was the issue. Nodes lock. Wait for buckets. Vector arc buckets. What is going on actually? I'm not. Bucket. Oh, so I have a single bucket, right? Node references. Okay, and then what's going on? Iterator mute. Yeah. Dot nodes. What? Dot. No. Okay, maybe I go back here. Hold on a second. Bucket. Maybe I just call it bucket. That makes more sense. Because I already have vector bucket. Sure. For I in bucket dot nodes. Nodes, right? Nodes dot lock. Lock await dot iter entry. Fine. So wait, iter what? Iter mute. Oh, that works. Interesting. Then what I can do is actually mutable entry. Let me let's comment this out. Let's change the name to entry. And let's go back to node references. Okay. And then what I'm gonna do is node references, and what I can do is change the last scene to the current time. Yeah. Okay. Is that right? Now routing table. Okay. Let's do that. So in my start node refresh, let me see. So I original routing table using recursive task. Interesting. Let's do the Tokyo spawn first, right? Okay. Spawn this, right? Okay. and then add the semicolon to indicate the end of the task. Got. Wait, move on. Yeah, right. So put it right here. Good. Okay, respond. So, what are you talking about? Sure. Node entry will take time. Oh, wait. Got the last scene. Yeah. Let's mute. Mutable self. Interval. Right. Won't take. Then am I doing it right? I think it's right because I would want to start the interval first before the function. Well, let's take a look at this interval. I have my node entry. Right. Node entry is going to be start node refresh. Now my duration, sure, bucket in buckets. And that's going to be started up there. Okay. And what I can do now is spawn. Yes, spawned it. Yeah, and then rate it, weighted it, iter last scene, signed it. Does this work? Sure. Why is this indentation going all whacked up? What is with this indentation? Okay. Spawn. Nothing to spawn. Oh, this async move. Async spawn should have in where exactly? Async move. So confusing to me. Async move. Okay. It should be outside. Async move. Make sure you type it out correctly. Don't waste time. Let's go ahead and fix this. Fix arguments. Yeah. Okay. Fix on the closure. Meowed. Okay. So closure. Let's match parentheses. Let me go back. Sure. Give me 1 second to figure this out. Right. So let me post this and ask for some help. Vector main rs. Sure. And what I'm going to do right now is go to the router table. I'm almost there. That took half an hour. It's spending like 5 minutes. Target time. Let's figure it out. What's the delay? Let's get that done. Start node refresh. Let's see if there's an issue over here. Move loop. What's going on? Refresh hand. What in the world? Oh, I see. Interesting. Let me see. First of all, let's confirm that this works. Okay, that looks fine. So we'll refresh. Let's name it something different. Sure. So the whole point was that I spawned it, and I think I can get rid of this stuff first. Tokyo spawned, and so Tokyo spawn must be passed in an async block. Right? I think that's the whole thing. Yeah. Then let's see here. What I have is async move. So I got here. Where's the interval from? Actually, what is that interval? Oh, I had to convert. Yeah, I have the interval. Sure. Interval. Right. Interesting. So I only care about doing this guy interval. In where you see move. No, we did that actually outside as well. So you can see that we'll move it back right. But I do want to spawn a future. Let's go. Oh, we assign let mute interval. Okay, fine. Interval. I'm not sure what's going on. Interval. Interval equals interval, and then that is inside my spawning of the Tokyo task. Okay, and then interval, and then I want to. Why do we do assign interest? Self like this. First time I ever had to do that. Self like that. I mean, async move. We do an async move. And then inside this move, I'm going to have a loop, which is going to do the interval tick ahead. We'll loop. Okay, we looped it. Sync move. Close it. And then, that should be fine. One more bracket. Yeah. Looks good, looks good. It looks good. Why is it not working? Refresh. So now we'll start the no refresh. Do the loop. Alright, so we have a loop. Perform. Did I have to update the main for this? Build. 247 has an issue somewhere. 322. Sync. So maybe no refresh. What is going on here? Sync no. Spawn future. Yeah. Spawn future. Inside my actual. So this guy. Let's see this. Close. I think that is correct. Routing table is just this. Does not have right. Let's check out the delimiter. 22 plus 2. Let's see where the routing table closes. But maybe it doesn't close. It's an issue. Need another one. No. Fix syntax error. I'm asking to fix the syntax error. Right, evict order policy. Let's talk about order policy. Come on, let's keep focus, keep moving. Fix the order policy. Fix syntax. Fix syntax. Nodes. Okay. Recursive logic. Fine. Bucket splitting. Two-level logic. Recursive bucket splitting. Sure. Track bucket levels. Level routing. Keep splitting. No lookups. Iterative lookup. It's fine. So I have bucket splitting with multi-recursive. Sure. Fix syntax. No, okay. Old comments. Old comments. Old comments. Please, thank you. Okay. 35 minutes in. Let me take a look at this. Implement cursive. Yes. Modify the split bucket. Recursive is still async. Recursive is a little interesting. It remains full. Oh, you can remain full after splitting. Interesting. Each split creates new buckets based on the most differing bit. Non-splitting does not contain are very large, leading to repeated splits. You pair same ID. Yes, it's in the middle of splitting. Yeah, probably immediately exceeding its capacity. How's that possible? Maybe I didn't receive the message. No, it should be a message. Try to include a new node that will cause the overflow, cause the bucket to overflow. Okay. Right. And copy that out. So what exactly was the code change? What do you think? So step 1, splits a bucket into 2 buckets recursively. What's going on right here is that I have a buckets, yes, get split. Oh, right. Okay, so arrange option with index, sure. And then get the nodes, and I want to iterate over it. Fine, redistribute them. Okay, so my distance again for a local node ID. If you remember, node ID dot distance. That's not really clear to me what this local node ID thing is. Let me see. Node ID is the okay. So it's the owner. So my owner. So how far are you away from? How far is the neighbor away from me, being the owner of this routing table? So I'm going to say this is the distance, which determines, okay, let's say it's on the left side or the right side. It's equal to 0. Okay, so the most significant bit, or something like that. So if it's 0, we go to the left. If it's 1, we go to the right. Yeah, you can imagine the binary tree that divides, right? Replace the original bucket with the left bucket. Why? Because we split. We split. We have 2 new buckets. Okay, and we can insert it into the list of buckets. Original bucket with the left bucket. Okay, original bucket with the left bucket. Put right. 2 bucket index plus 1. Check if further splitting. Interesting. So how would I trigger that? Let me see. Bucket splitting. So how would I trigger that? Let's go back to this. Repeated bucket splitting. So it's repeated bucket splitting. Yeah, bucket splitting. And then let me build it. Right. Shoot. Mutable self. So it's read. Accident. So synchronous context. Self ref. Just instead of mute self, since it needs to spawn independently, the routing table across the task. Clone the arc for the background task. Pass into the task. So ensure the routing table lives for as long as the task needs. Okay. For last scene. Clone the task for as long as the task needs it. Okay, what was the issue before? How self is captured. Task. Okay, it's moved. I thought I got a reference. It's not a reference, apparently. So, what is it? Let me see. I did in the middle of my thing. I'm like, what? Oh, okay. Maybe it's just more readable that way. Refresh handle, sure. Okay, so what I did was that. Okay, almost there. No refresh equals to what exactly? So we had the interval, sure. Now I want to clone it self. Okay, so I can clone the self, and that will give me we could move the clone because it's just a counter to the number of references, a reference counter. Sure. Okay. And spawned it, and we looped in. We ran the function. Self, I cannot clone. What? Oh, it's arc self. Self is an arc self. Arc self. Interesting. Don't really get why an arc self works. Okay, arc self. So this is the keyword self. Okay. Sure. Self is the keyword self. We cloned it, and then we're gonna pass it in here. Self ref. I don't need this self ref. So clone. I cloned it. Was I able to update it? No. Self clone. I mean, I don't think that works either, right? Nice. Clone. It's ready. Let me see. Self is not exist. Probably it's not implemented. Cannot assign to data in an arc. And then self.clone. Hey, did I clone this thing? Makes arc.clone equals self update task. See this guy, self.clone. So I cloned it, right? What's wrong with this? The data to an arc. Not assign data. Assign data to an arc. Clone. Reference it. Nope. Let's see. Handle Tokyo join handle cannot be up to reference. An option cannot be dereferenced. Cannot be dereferenced. The update task. So implemented by sync table. See how they did it. Self update task. Okay, you should be able to update it really simply. Apparently, we spawned it. Yeah, and then we moved it inside. Okay, looped it. Sure. Updated the last scene. Sure. Okay, updated. We updated the task. So I still pass in. Can I access it like that? I need to clone it. Even. Let me see. Self. Right. Update task. Assigned to an arc. It's the reference. Why is this? It's the reference. That's why I am a little confused. The reference mute. Yeah. So if you see refresh handle, yeah, Tokyo spawn. So I spawned it. Yeah. Ran in the loop, updated the task, stored the task handle, and then let me grab this error briefly. Go back to this one here. Reference mute is required to modify to its reference, but it's not. For this routing table, got it. Routing table. And then, where's my routing table? Here, routing table. Update task. There's routing table, and then my routing table here. Node ID, yes, I have as well. ID is routing table. Node ID, fine. All fine, all good. Node entry, okay. Node entry, yes. Node entry, that's what we're talking about. Okay. So what am I missing here is I have node ID, right? And I'm missing a fetch. Wait, let me paste it first. This is going to be, let's see. So it said, yes, I could not assign to an arc, fine. But how about an arc in the self? Okay, arc with the self block. Sure. So I cloned it first. I spawned it, moved the clone into the asynchronous closure. You're right. So this is a closure. This is a block. It's a closure. It looks like. Okay. Let me see. Arc does not allow an actual mutable let's see, it does not allow mutable access to its inner data directly. This makes sense our design. Slightly tricky. Bucket default. And then the task, new text to allow mutable access. I don't get the solution though, so I locked it in access. Assign data because it's not allowed. It's not allowed. You think move. Allow. This is data right. With mutable references by default. Mutex which provides mutable access. Interesting. So, let me see. Update task. I think so. What they're saying is my option here. Should be wrapped inside the mutex. Okay, should be wrapped inside the mutex. What I'm doing is, I'm going to unlock it, right? If I want to, okay, let's go back here, update it, unlock, unlock, right? Unlock, lock, was it lock? Lock. Oh yeah, lock. Oh wait, right. Wait is okay. Lock await. It's a mutex guard back here. Let me see. Where's mutex guard? Okay. Looks good. Looks good. Mutex guard. Right. Come on. Here's mutex guard over the handle. And then I would say refresh. Refresh task. Good. Refresh task. Refresh task. Okay, let's go back here. Refresh task equals to what exactly is refresh? Okay, if you're not assigned, sure, but you know, option. Okay, and then since I locked it already, yes, not mutable. Fine. Okay, so we're at submit. Okay, let's take a look. Expected. Okay, update task. Yep. Update task. Let's talk about the actual references. Not this one. Okay, refresh task. Let's go here. Okay, task, right? And then none does not work. So what was it? The task mutex of new over none. Interesting. Mutex new over none. Okay. Works. Let's figure out if we can handle the error maybe later. So can you try to run it and see what happens? Yeah, sure. Okay, and then successful run, I think. Yeah. 2, 3, 4. What is its expected output of this? What is the expected output of this? Let's see. Just go to check the actual value, and what I need here is what exactly? Let me see. So, what's expected output? Expected output of main. Expected output of main. Right. Expected output of main. Okay, and I go back to my actual split bucket. Okay, cursive. Okay, let's go back to split bucket. Cursive logic. Task. Good. Let's wait for him to finish. Fine. What's going on? Let's see. Output of main. Oh my goodness. So is it actually correct? Y'all knows display the contents. Yep. Since all different from the first byte does not return capacity. Okay. Good. Let's go to recursive bucket splitting. Okay, no, let's first come in. Yeah, let's add it, and then let's take a look at this SGPT. Okay, SGPT, right? And then to recursive bucket splitting. Okay. Yeah. So what's there? Refactor it. Yes. So I refactored it. Oh. Oh. Let's see. Undo. Let's commit. No. Amend. Can I undo as reflog? Reflog commit is set to here. Okay. Commit amend to sky and let's go back to commit amend. So I'll take around. Let's keep it focused. Let's keep it on track. 2, 3. Okay. Commit history. Yep. I did commit. Sure. Blah. Can I undo the amend? Amend for the amend, and then applying changes. Right. Looks okay. First commit. Can we change stage? Yeah. Right. Visual content. Let's just try this. Okay. No. Okay. Good. Okay. Looks good. Looks good. Factor. Commit. Factor for produced. So what was the whole point of exercise 4? Was actual eviction. Yes, least recently seen eviction. I think that was what I was trying to do. You see, least recently seen eviction. Bucket eviction, node eviction, bucket eviction, eviction. Okay. Yep. Sounds good. Okay. Log line. Right. Recently seen. Okay. So what am I doing here? Yes, let's go to exercise. Let's jump down. And then handling bucket splitting. Okay, recursive approach. Recursive splitting is full. So do I need to, let's go back here. So I don't have a split bucket function. That's interesting. I thought I had split bucket function already. I did split nearest. Is that what they're asking for? Split nearest. Where did I get this? Not sure. No, it doesn't look. It looks like it's okay. Let me quickly. No, blah, blah. Okay. Isn't redistributes the node. Function determines which buckets to split and then redistributes. Sure. Okay. Index pits logic would determine the nearest bucket to split. And then what is going on here? Nearest buckets index and split point. Okay. Nearest bucket. Yeah. Okay. So split. That was what I don't understand. Split bucket. Okay. Split point. Okay. Did I actually use this guy or what? Oh, I did this one. Bucket index. Interesting. So what happened? What was the change? What's the change? So still, yes, quite right now. Okay. So usually get split point. Okay. Wait, let me see. Yes, this nodes, right? So I got for my 0. So now let's pass in as an argument the bucket. Okay, create the 2 buckets I'm going to split into for this bucket. Good. Okay, and then, okay, I want to get all my nodes, but this should be a reference, I think, right? Yeah. Oh, so it's cloned, right? So clone. Yep, that's right. We cloned every single entry. Let's go back. Right, and then need to determine whether the left or right bucket. Okay. So is this right? Let me see. Left and right bucket, and replace the original bucket with the left bucket. Okay. Yeah, sure. Let's do that. Okay, split the bucket. So instead, this might be a slight bit of a hassle. So what's the point of the node then? Actually, I'm not too sure. Let me see this guy. His references. Oh, that's it. So to add node, he's splitting. That's interesting. I should split buckets. Yeah. So who calls this guy? Here's bucket. Here's bucket. Add node. Well, I mean, we can always do it again, I guess. It doesn't really matter. Okay, let's just do it for clarity. So I think it should be async. Also, why is add node not async? Oh, yeah, because I'm returning. Oh, yeah, this one was complicated. Right, so just to make sure that let's see, because I wanted to pass self or what? Let me see. I think it's just because of syntax error, right? Got it. Okay, let's go back here for nodes. Okay, let's quickly bang it out. Yeah. So what I want to do is I want to split bucket. Am I splitting one? Yeah, I'm splitting one bucket. Okay. And then I want to pass in the index, bucket index, bucket, the actual index I want to split on, right? New size. Okay. And what I want to do right now is bucket use size. So let us first lock the actual bucket. Let me see if I can find. Let's break this back. In the routing table, yep, routing table. Let's open it. Good. Okay. Okay. So self. I want to access the buckets. Want to read or write. Let's do read for now. I'm not sure. Read. I never actually had to try read before. What did we call it? We write it. Okay, but we still call it buckets. Okay, fine. Descriptive, sure. Okay, see when this read goes wrong. Sure. Okay, what should we do next? Is I want to determine the split point using, okay, and then I want to retrieve, okay, I want to retrieve index bucket at index. Okay, retrieve bucket at index. I want to retrieve the bucket at index. So what I can do now is, so I have my buckets array, and then what's going on is I have my buckets index. So right, okay. Okay, so I have my buckets index, and then what am I doing with index? Okay, split bucket. What do you call it? Split bucket. Okay, just bucket. Okay. Anything bucket split. I don't want to move it out, right? Okay, good. Okay, so acquire the reference later. Why do I need to acquire the reference? Split buckets. And what I do now is turn the split point, because there's a function called I don't know this one, split for this bucket that should return determines where it differs the most. ID get split point. Actually, yeah, I get split point. Okay, yeah, and then we do some math stuff. That's fine. So where it changes the most? Where are you? Split point. Okay. Right. So I want to get the actual split point. Right. Okay. Split point equals to bucket this one that we're splitting on. And what I'm going to do is get the split point. There's an option with the U side. What's going on? Point. Split points. Future. I think it's async. That's right. Wait. Okay. Got it. Wait. Okay. And what we can do now is So sorry about the split point. Create menu buckets. Create two buckets. New buckets. Buckets. Okay. And then let's look at the definition of the bucket. Right. So arc here. Mutex equals to left bucket. Let's call it left bucket. Left bucket. Left bucket. Right bucket. Okay. Right. Right. Right bucket. Okay. Left bucket. Right bucket. Got it. Okay. And let's go to what exactly is arc new or what arc bucket? Well, it depends. I mean, how's it stored in your routing table, right? So buckets is the actual routing table for arc new. This buckets have a new. Let me see. I think so, right? Node introduce size. No. Wait, how do we do this bucket? Default. Did I have a yeah, here. Okay. Default is max size, prefix length, and then we already have this as like a control. Okay, fine. Okay, so we created this, right? Default. This one. Okay. And then what I want to do is go back to this node. Okay. Let's keep moving. Okay, almost there. One rep. Okay, so I just split it into two buckets. Into two buckets. And I want to do the actual. So I got the split point. I could retrieve my nodes that I'm actually splitting on. Okay, retrieve my nodes. Yeah, that's why I try to like split point, get split point. Get split bucket. Okay. Right bucket. So what I do now, I iterate over all these nodes, and then I'll determine if. Okay, then what I want to do is iterate over all nodes of this bucket. Bucket to split on, and then check if if most significant byte is left or right, or something like that. Left or right. Yep. And then so how do I get it? So there's a way. There's an option. List nodes. Where's here? List nodes. And then how do I do? Okay, I cloned it. List nodes. Okay, fine. List nodes, and this is a bucket function. It's an async bucket function. Okay. And what I'm going to do right now is async bucket function. Okay. Let's go back to bucket, and then buckets. Let me see. Get bucket function. Oh, let's go back here. List nodes. Yes. Get my actual list nodes. My actual nodes. Current nodes. Oh, that's going on. Okay. Yeah. List nodes is future. If you remember. Okay. Come on. Wait. Current nodes. Okay. We get our vector. Sure. Yeah. And then what I want to do right now is I'm going to iterate over all bucket nodes and buckets. Check if it is left or right. Okay, so what can we do here? What can we do? Yeah, and then iterate over the buckets. Okay, so I'm gonna iterate over the buckets. Yep, current node in current nodes. Vector. I think this consumes it though, right? Vector. Oh shoot. Let me see. Nodes here. Your node, does this consume it? I'm pretty sure. Let me ask. Does this consume? Does this consume? Yeah, I think so. Let's see if it's enough. Oh, what? Okay, no, it's not. What the heck? Wait. Iterates. Oh, it uses the iterator, right? Okay. That means iterator lowest reference. Okay, so is to iterate. Oh shoot, iterate. So reference node ID. So how does it? What's going on? Effect with a for loop inserts of pause immediately. Okay. As soon as it reads it. I'm not sure about that, but okay, and then we do the math. So basically, so this is left. This is left, and then that was right. Insert right. Okay. Insert right. Insert left. Okay. Okay. Yeah. So right now I'm splitting my bucket, creating my buckets, iterate over the nodes of the bucket that's chosen. Right. And I'm going to take those nodes and distribute according to the XOR algorithm. Okay. Insert left. Sure. Insert left. So I have my left bucket. And what I want to do is do here. This is a vector. What's going on? Let us go to our bucket. It's not. Let's push this back. Okay. To my nodes. Yes, I need to lock it before I can access it. Fine. Nodes lock. Good. It's awaited. Yes, awaited. I'm pretty sure. Awaited, and then what I want to do is push. Push current node. Push current node. Fine. Okay. Current node. What happens after that? Push current node. So node ID. Push node ID. Can I do this? Oops. Huh? What happened? Is it worse? No. Yeah, so I'm saying, man, like current node is a reference, but does that F things up or what? Node. Oh shoot, because nodes is node entry, right? Okay. Current nodes. What's going on? This nodes. Let's see. That's why I think I got a little bit confused right here. ID distance. So distance is distance of me of my current node. Wait, but let's take a step back, right? For current node, yep. And for bucket, so of the nodes in the bucket, that should be this node is what? This node was a node ID. Okay. But how about here for my node ID? That looks fine, right? Node ID. Okay, so now I have node ID, right? Node ID. And then what I wanted to do was distance. So remember what the distance was. It was the result of XORing my current guy, right? Distance node. Where's the XOR node entry? Is it no? Right, distance of node ID, right? Of my current no, of the node I want to split on. Bucket I want to split on, or the node I want to split on. Let me see. I think it's going to be the actual bucket. Yeah, buckets of this node, right? Okay. Bucket levels, right? Check what is going on right here. Oh, that's an edge case. No. One step at a time, man. Like this node. Okay. So I was at the distance, and then what I need to do now is I need to find my distance, sure, of what exactly. Let's see. So I want to find my node ID. Okay, node ID. Okay, current node ID. Let's see, current node ID. That's something that this right. Wait there. Current node. Right, 90 is reference. Good. Okay, so the node that I chose. So who? That's my self. Okay. Local node ID. That's right. Local node. Local node. Oh shit. ID. Okay. Routing table. Okay. That makes so much more sense, man. What the hell is going on? Node ID. It's just node distance. Okay, so and then so I'm in the routing table. Yes, I'm gonna check 90. Actual distance. Distance is asynchronous. No, it's freaking synchronous. Okay, let's match this. Okay, let me see. Push the node. Split the bucket. So, right. So did I do all this? Let's go up to here. Yes. So I got the nodes. What happened? I got the nodes, and then so I checked my routing table. So my owner distance from each of these nodes, right? And then determine the split point. This one I didn't really understand. It's fine. Okay, what's wrong with this one? Entry match node entry. Okay, so how about this one? So what do you think? Node entry, because what is the actual constructor of this constructor list? So remember node entry, and then last scene. Do I have Chrome debug node entry fine? Last scene instance. So maybe create a new one. Yeah, I think that's node. Whoa. Nodes iterate node ID. Oh, I think that's why I messed up left bucket. The add. Oh, it has an add node function. That's why I messed up. Okay, because I was in the bucket. And then yeah, this one. Okay, makes sense. How does it work? Okay, lock. Yes, lock. Right, because it gives you. Sure. Otherwise, we evict based on the task that's running in the background. Got it. Okay. Add the node. Okay. So what can we do here is we locked it. We pushed. Okay. I think yes. Right. Let's get rid of that. Okay. And then what I want to do right now is I don't even. Let's go back to the bucket. Bucket, add node. Wow, node, and then what I want to add is a current node. I believe current node is just node. Node extension node equals to. Oh man, am I doing this right? Add node. Wait. Yeah, it's not working. Add node. So this is for the bucket. So I'm accessing my bucket. Yeah, sure. And no. Okay, right. Node ID. Right. There's behind the shoe reference. What happened? It's a book. Yeah. Okay. We iterated this. Add node over node ID for node. Current node. All right. No. Dot 0. No. That's why. Let's see. Dot ID. Since when did I have a node dot ID? ID. I don't think that's a thing, man. Like node.id. Let's okay, so I think it's pretty close. Let's go back here and let's put it in. Sure. Yep. So what node is going to be node ID? Add node on what exactly? Node ID. Why? Oh wait, just clone it in mother. Right. Come on. Move on this bad boy. Yep. Going on this bad boy. Wait. This bad boy. This idea. So you're telling me what's going on? No. Version. Hold on a second. Telling me every time we split, you want me to, consumes the memory. You should be very aware of when it consumes memory, when it's race conditions, when you change ownership, sure, when you change asynchronous and synchronous. Okay. So I think I'm missing is add node. Okay. Right. So every single bucket he adds the node. is the node. Yeah, I have my node ID. I cloned it, right? Because if you look at the definition, it's node ID, right? It's just the slice 20 U8 slice of 20 entries of U8. Okay, yeah, okay. And then what I can look into here is, and redistribute them based on the split point. Yes, sure. Replace the original bucket with the left bucket into the list of buckets. Okay, what am I missing here? Bucket with the left bucket, insert the right into the list. Sure. Further splitting is needed. What happened? Bucket. Does my bucket have? Yeah, I think that's the problem. Okay, I have node entries. Okay. Nodes that lock. Sure. I'll wait, right? And then that link. Okay, what's what I need? I think that's what's the problem. Okay, replace with the left bucket that nodes that lock. Interesting. I don't want. I mean, you already cloned every single node already, right? Check if further splitting is needed. Have buckets maximum size. Let's go. See, this is the one I don't quite understand. Logic wise, just seeing like what is going. How? Let me see. Bucket splitting. So let's go back. Right, not to this error, but to cannot assign to arc. Yep. Yeah, sure. Not sure. Don't get step five. Step five. Okay. And then just go back to 4.0. Yes. And then let me load this screen and then see what happens, right? So let me regenerate. Sure. I think it's fine. Okay. So yeah. Okay. Maybe I can get step 2. Okay. Bucket levels for multi-level routing. Interesting. So what the hell's going on? So I modify the bucket to, okay, so each bucket, we already have routing tables to buckets, right? And then so on and so forth. Okay, so buckets every level inside the bucket based on what exactly is the bucket's incremental level as the split, update the splitting to incremental level as the bucket split. Okay, there's no interesting. Track bucket levels. Splitting should be incremented by 1. The level field, multi-level routing. Interesting. 5 is about checking if further necessary. Might still exceed its maximum size. Okay. Step 5 in the code is about checking if further splitting is necessary after the initial split. This step is crucial because in some cases after a split, this bucket might still. That's why I don't understand. How can I understand? Okay. Split high intensity, it's visualize. So I think it's always good to visualize this. Okay. Check it exceeds, right? What should we call split in the bucket? On it. Okay. High density. Visualize. Sure. Divides nodes based on single. Oh, okay. For several bits beyond split. Sure. Nodes if the node shares the same prefix for several bits, end up in one of the new buckets. You see, I see. Yeah. Okay. Okay, that means to cluster together. I see. Okay. XOR. You from split, bro. Concrete enough. Create indeed enough. Okay. Enough. Visualization. Including values. No. Actual. Like binary values. One. Values. Bit makes sense. Split again. Okay, got splitting, sure. So second split, right? Based on the next significant bit, which is bit 1, sure. Right, and the second bit goes into bit 1. 1 into the second bit goes into okay. All right, so it has 7 nodes, which exceeds the max size. Yep. Let's go back to here. Sure. Split based on the next significant bit. Based on bit 1 nodes with 0 and then bit. Okay, got it. So okay, in the middle, yes. Okay, yes. So this is second bit 0, yeah. So it still exceeds, right? Splitting. Recursive bucket splitting. Okay, recursive bucket splitting. Let me see if that. Recursive bucket splitting. Recursive bucket split. Okay. So bucket split. Okay, good. Okay. Recursive bucket split. Okay, makes sense. So let's go back here. What I'm missing. So how did we do it actually? So because I assigned it here, right? And that definitely takes ownership because buckets is own data. Okay. It's arc thing or what? Buckets of arc. Vector arc. Of what? Wait, let me read arc buckets. Okay. Oh, that's routing view. Back to routing view. Cool. And 2. Okay, visual arc buckets. Sure. Arc buckets. Okay, no. Lock. Right. So I can't. Well, I mean. Let's see. That is interesting. It's interesting. Probably would value to try to build it again. Yeah. So let me try to build it again. One quick thing. Yeah. So let's go back to our Amelia. Okay. And then yeah. So what I'm going to do right now is I'm going to target from this guy bucket. Node ID bucket, right bucket, but okay, yes, sure, bucket, and then copy this. Okay. Did I press? Okay, good. Use right here. Okay, good. Let's see. Okay, almost there's the bucket. Okay. Yeah. So what I'm interested in doing, no, that's not what I do. Messages, clone arc. Interesting. Right, log. It's cheap, it just increments the reference count. Without changing the structure. Let's see. Node, right, bucket. My goodness. Okay. Right. Let me see, right, so split the buckets. Yeah, so yes, sure. Okay. Where was the difference? So I still get the split point, got it. And then we listed the node, fine. Okay. And then we retrieved the distance, sure. And then we added the node. I cloned it. That is correct. That is okay. Our clone of the left bucket. And what is the left? I thought bucket is like, oh my goodness. I see. So, because it's a vector of buckets, right? Okay, I see. That's a vector. This is a loop or something, or what? Bucket index in there. bucket index, split bucket, or bucket index. Split bucket index. Did I call this guy or what? I don't know. So what? This one. Okay. Is the splitting? Yes. If I hurt bucket index. Split bucket. So this guy needs further splitting. Okay. And then interesting. Okay, left bucket. It's an arc. Clone. Alright. Okay, left right bucket. Same. Okay, clone. Okay. Let's see. Okay. Recursion requires boxing. Is that true, man? Like, it's like now I get like this kind of stuff. That's why I'm a little like, what? Let me see. Drop right. Let me see. That's a little interesting, actually. Drop the right lock. So why did he drop the right lock, actually? So we cloned it. Yeah. Or cloned it. Yep. Yeah, sure. Inserted it. Yeah. I cloned it. Right. Okay. I think our clone might be better, because it's really not obvious to me what exactly the type that we're cloning. Cloning. Oh, let's go. Left bucket. Oh, so now to pass in a reference for this guy. Okay. Reference, fine. Okay. Cloning. Yeah, sure. Cloning of the reference. Okay. So what am I missing? So why we drop for making recursive calls? Void deadlocks. That is interesting. Actually, that's interesting. Why drop variables? So we can left bucket variables. So we can lock it. Bucket max size. Interesting. When dropping the right lock, there's a risk. Recursive calls. We try. Interesting. Modify between splits. Because what is the lock that we are acquiring, actually? Because remember, interesting. So buckets stuff, right? So what is this? So the buckets. Any routing table doesn't have to be this. Yeah. If I have a task that's trying to edit my buckets, added by this routing table, and then if we need to update the split bucket as well. So before recursively splitting, I could defer. I could not defer. I could in turn swap in. No, not swipe in. Swap in. Yep. Swap in another task that wants to split the bucket. Yep. Okay. Sure. Drop it. Okay. Interesting. Recursive lock. Fire deadlock. Sure. Let me do that. Okay. So let's explicitly drop it. How do I drop what? Drop what? Buckets. Bucket. Does that work? I can drop. Oh, I can. Yeah. Okay. Same thing so far. Okay. Build. Okay. Let's keep moving. Hey, there's some interesting shit. Okay, split, because if I don't want to recursively lock. Okay. Let's keep moving. Okay. Right. Yeah, so what I need to do right now is adding a peer. Sure. Track multi-level on bucket level routing. So actually I'm gonna visualize that later on, and then see like how exactly we can do this multi-level routing thing. right? Yeah, level routing thing, concurrency, spawn. Here's lookup. Okay. Co-optimization, so my spawn conflict resolution. Tree strategies, negative. Yeah, never churn. Interesting. ID prefixes. Do this. Hash map. Adaptive node aging. Good. Resilient handling of network churn. Right, replication. Yes, finally. Replication. It is replicated. Okay, so it's consistent, up to date cross replicas. Interesting. So how do we do replicated cross? Merging logic, adaptive, efficient routing, iterative look. Okay, some routing track buckets. Okay. 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 So what I need to do here. Okay. Interesting. So they should just the same thing as well. Size. Wait, Rust needs to know the size of the feature compile time. Cursive. Okay, convey unbounded size. Needs to know unbounded size. Fix this. We need to use box pin to create a dynamically sized future. How we can modify the split bucket function to handle this. Dynamically sized future. Dynamically sized future. Okay, so this is a dynamically sized future. So in that case, is that it? Like that's all? Oh, I can't do a wait then, or what? No. Oh yeah, and then we have to. So what the hell does it mean? There's a big pin. Okay. Return future that returns nothing. Sure. Borrows from self for its entire lifetime. Need to await a split bucket. Okay. And let's see. Let's move this here. Let's move this down here. And then let's put this on a little box. Yep. And then signature. Boxing the futures in a known size. Moved in memory. Sure. And we split the bucket. Okay. And then what else are we gonna do? Okay. So we have the write and then the wait. Yeah, sure. We read it, we wrote it, and then weighted it. Okay. Split the bucket. Okay. Consensus. Okay. Consensus. Right. And then wait. Schedulers. Okay. Bucket. Some split point equals to what exactly? Equals to get split. Yes. Okay. What I need to do for this to work. This is all right, but I need to put it in a enclosure. I think box pin. Box pins. Okay. We're pinning this value. Grab it, right? Putting this inside. And what I'm gonna do is let's just do an async. Async for now. And let's create this block. Yeah, let me move it inside. Sure, right? Sync. What is this? What's going on? What's going on? Sync. Is this one? No, what is that? Async. Here. No. Okay. Sync. But it borrows bucket index, which is own. Lock. Yay. Let's see. Lock is Explain, please. So 8, please. Okay. You can set the execute block you're using might outlive the current function, but it borrows block. Okay, but here, right? Yeah. Yeah. Okay. Execute block. Yes. Bucket index. Sure. Its own is problematic, right? Because outlive block can hold up. Okay, let me take a look at this bucket index. Sure. How can we do this? Bucket index. Yeah, moved it. Okay, so let me try this. Okay, so and I try to refer. Live. Okay, am I borrowing it? Is that what's going on? Okay, index. Reference. Okay, fine. Yes, sure. Okay. 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 Got it. I'm trying running it. Okay. No problem. So, recently seen split. This is going here. Yeah. Okay. We need to wait it. So do I? I don't think I called it yet. Split the buckets. Recursive logic. Recursive bucket splitting logic. Okay. Let me add this guy. And then let's uno it. Yep, SGP, and then let's go on here. Bucket splitting, check, bucket splitting. Yes, bucket splitting. Okay. Distribution, yep. Okay, bucket splitting. Demo size. Oh, got it. Good. Okay, bucket splitting and routing table, but okay. Inserted, sure. Line, splitting. Splitting track, multiple levels, multi-level edge cases for deep splitting scenarios, optimize node routing. Okay, so track bucket levels for my multi-level routing. Sure. I think that's what I'm doing. Okay. Okay. So let's see. So am I routing? Okay. Bucket level routing. Wait. Block this. Stop sharing. More exchange. One. Ceiling. So what need to now is here. Right, so yeah. Right, so what we do right here for this one is reference. Okay. This one reference value, sure. And okay, so let's go back to my actual function. Yeah. Okay, so yes, wait. So I split the bucket. Yes, track levels. Okay. So interesting. So let me visualize. Okay. Let's go back here, and then let me visualize this bucket level thing. Here, explain. So level is update during bucket splitting. Interesting. So level European deep splitting scenarios. You can see, so there's a number of splitting ways to split, right? Construct now includes a bucket, right? This is 5. Bucket level. Person split. Okay. Uh, Visualize for this. Okay, got it. Using levels during splitting. Sure. What I want to do right now is a level field tracks the depth of buckets in the routing tree. Max size of 3. Right. Okay, this looks interesting. Right. Interesting. Okay, good. How can we see? Let's see. Okay, so let's see how it splits. Node IDs are 4-bit binary values, and we track the level of each bucket in the routing tree. So overall 8 nodes. Yes, sure. Okay, this is going to be hard to split on. Okay, so let's go, yeah. And then we can split on the second, which of course goes 4 and 3, sure. Still exceeds the max size. Third split. Oh, so that's interesting. So we incremented the level. We said 4. Yeah, which is you can just visualize the binary tree, right? So we split it into level 1. Split level 1 further into, right? So split into level 2. Okay. Okay, got it. Now split bucket 1 on yes. Okay. Yes, sure. Now split bucket 1 based on bit 2, which is level 3. Okay, that is a little interesting. So we split bucket 1 based on bit 2. Yeah, based on bit 2, bit 2, excuse me. Yes. So that is bucket 1. Yeah, fine. Okay, 3, got it. Visualization. Within the limit. Okay. Improve that visualization. Improve the visualization. It's all clumped up. All clumped together. Okay. Okay. Right. So let's see. Everything's much different. Wonder. Interesting. 3. Right. Round at 0. You're ready to visualize the tree with the limits bit on bit 1. Okay. Sure. And then bit 1. 0, level 2. No, I think the last one is actually better. Okay. And then we can do splitting on levels. So let's splitting on levels. Splitting levels. Good. Splitting levels. And what we need to do now is actually implement the levels. So makes sense. Okay. Track the bucket levels for multi-level routing. So you can see here level or depth field to the bucket structure to track its position in the routing hierarchy. So modify the routing, the bucket structure to include a level field, which is how deep the bucket is in the routing tree. Update the bucket splitting logic to increment the level as buckets split. So how can we do this, right? So what is going on here? So in my bucket, right? So if you remember how we're going to keep track of this, right? So each bucket has to have maybe not awareness of whether he's left or right, but there should be a field, there should be a subfield, there should be an instance field, there should be an attribute, yes, level, just tracking the current height current depth in the tree. This bucket is this. Yes, it's split many times, right? Makes traversal easy, and to maybe later on add in factor in our actual calculation of this metric to whether or not it's worth updating. So you remember we dropped it, and so if I want to update to keep splitting, yes, and it takes too long, yes. So I mean later on, just factor in how I track it, how I track the entire thing. Yeah, okay. Track bucket levels for multi-level routing. Okay, so let us see. Further splitting is needed. Okay, and then so let's see here. If further splitting is needed, oh no. Bucket levels for multi-level routing. Okay, it's stored in this bucket. So maximum bucket for eviction is needed. Let's go back. Yeah. To what is it? Struct bucket. Let's go back to that bucket. Yep, bucket. Yeah, sure. Nodes. Yes. So I have my max size. I have my prefix length. Prefix length. Okay. You see how many places to use. Prefix length. Prefix matches. Just checked. Sure. How many full bytes? Prefix. Do that in the find bucket. Okay. If X matches the bucket's prefix, return the matching bucket. Okay, split the bucket. Find appropriate bucket for I don't get the prefix matching thing for bucket. Go back here. This up here. Yes. Up here. Prefix matching thing. Okay. Almost there. Get this thing done. Prefix matching. I don't get this prefix matching thing. Don't get a prefix matching thing. Can we do visual like for prefix matching thing? Wait, where's the visualization? Select prefix constraint. Let me see. Sure. Prefix matching node ID. Okay, prefix matching. Sure. Let me see prefix matching. Prefix length is 0. Sure. This bucket can hold any node ID into the bucket splitting not 2 bucket space on the most significant bit. 0 here. Let me see. Let me see. Right. So I have no prefix constraint. Yes. Initial. After splitting. Yep. 2 buckets. Okay. Length equals to 1. Okay. Interesting. This bit. 0. Yeah. 0, 1. Okay. So distance. Yep. Go back here. Yeah. Let's see. You make XOR distance between local node ID and the target node ID. If the prefix of the XOR result matches the bucket's prefix, check if the prefix of the XOR result when routing or searching for a node. The XOR distance between the local node ID and the target node ID. That is true. Okay, we check if the prefix of the XOR result matches the bucket's prefix. Okay, then yes, you have a node that belongs in the bucket. Okay. Let me see. Okay. Extract the relevant bits. Extract the first 2 bits. Compare to the bucket prefix. Does 0 match the bucket prefix 0? Yes. Okay. 0. So which bucket prefix was? Check a node with ID against prefix 01. Okay, first 2 bits. Extract the relevant bits. Okay, first 2 bits. I see, depending on the prefix. Okay, so depending on the prefix, right? Depending on the prefix, let's see. Going back here, I had prefix length. Was it prefix length? At prefix length, no, but I don't actually start with prefix zero. Okay, prefix length, prefix. Okay, just the prefix matches. Let's see. Okay, prefix length. Yes, in matches. Okay, prefix matches. Routing searching for the node. Visualizing. Visualizing. Searching for the node. Don't get this. Don't get this part. Don't get this part. 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 Searching for a node. Get this part. Okay. Searching for a node. X more distance between the local node ID and the target node ID. That's right. Right. Okay, routing, right, storing data, sure, according to XOR, distance to the key of the data, yes, right. Searching for the node. The point is to find the node, or determine which bucket a node belongs to, right? For tasks like storing data, when you want to store data or node, you determine which node is closest, right? According to XOR distance to the key of the data, what is going on here. When you want to store data on a node, you determine which node is closest according to XOR distance. Yeah, when you want to store data on a node, you need to determine which node is the closest. Yeah. Okay, got it. You want to locate a specific node, you want to determine which path bucket to follow to reach the target node. Yeah, okay. Which path, which bucket to follow? Sure, because the bucket splits into different nodes. Based on what exactly? Using the prefix. Nodes tree structure. Nodes ID between the target node ID. The bucket needs to search in. XOR distance gives you a binary value. Okay, check the prefix of this binary value. Check the prefix of this binary value to determine which bucket you should search or route the request to. Turns the bucket to search in. Let's see. So, okay, suppose your routing table currently has buckets split by the prefix links 1 and 2, right? If you match the prefix, yes, suppose, okay. Yeah, okay. And so prefix of the XOR distance 0110 these buckets. Those are routing table currently has split by prefix links. Okay. Yeah, sure. Things 1 and 2. 0 is, and then next one I have like a 1 0 and then a 1 1. Yeah, okay, good. Measure prefix length of the XOR distance to these buckets. It's other prefix matching, right? 001. It's prefix 0. Yes, it does. So you search. Yes. And you find this new node, sure, target node, whether it's routing or storing, start finding node. Okay. So searching, sure. Right, across the nodes, you search within this bucket. Okay, the prefix says 0110, match the prefix 01. Yes, it does. Yes, sure. What's going on? It's one big 2-bit prefix. Search down within this bucket. Lines, prefix getting. Okay. Now redo this entire thing. Redo it now. Combine this and previous thing. This and previous thing to show entire process. Flow. Okay. Okay. Right. And zero. Find result. Right. Let me see. Previous measurement. Okay. Right. Check. Right. Target. Check prefixes. Sure. Zero is prefix of zero. So extra result zero. Start with zero. Yes. Zero is the one to search in. Yes. Zero is prefix of zero. So yes. Okay. So how many buckets I had? I had 2 buckets actually. 2 buckets. Splitting and then prefix matching. We said. Prefix matching. Yes. For splitting prefix matching. This means for a split. Sure. 0, okay, 0, 0, right, 0, 0, 0, 1, and so on and so forth, right? So we have a key space of 8, right? Because is it true 0, 1? No, we have a key space of 4, I think. Okay, 1. Yeah, I think 0, yeah, okay. Now go to search to bucket 1, which contains the values. Yeah, this target node is really okay. Prefix. Everything. Okay. Prefix matching, bucket splitting, matching. Search. So it's entire flow. Prefix matching. Search. Search. What was it? Search routing. Flow. Entire flow. Okay, let's go. Okay, let's go back to entire flow. Sure. Okay. Split. Okay. Handling duplicate. Maximum bucket size during splits. Max splits at a level or depth of the bucket structure to track its position in the routing hierarchy. Each time a bucket is split. Okay. Level of the bucket should be incremented by 1 and set the level of buckets. Okay. So what exactly is going on? Right. Okay. So pretty close actually. So routing, bucket merging. I think that seems important. Adaptive K values scale dynamically. Sure. Underpopulated. Okay. And then 7 we said. It's routing. Adaptive. It's not as important. Let's see. Okay. So what I'm doing right now is where's the bucket spinning? Okay. So let's actually track the levels. Okay. So just try to get it out and how we're trying to do. Okay. Add a lower depth field to the bucket structure. Sure, in the routing hierarchy, so I want to have the levels. If the bucket structure include levels, let's look at bucket structure. Include, let me fold this again. Buckets. Okay. Okay. What's going on? Okay. Levels use size. Okay. Levels use size. Good. Use size, maximum size. Good. So number. Wait. Size depth of the bucket. Running tree. Okay. Default. And then I have set level. Okay. So let's check out what I need to implement for my level. Find. Okay. Level 0. Okay. Level 0. And then right here. Level. And then I want for bucket implementation. Let's just do a simple function. What's going on? Let me get the level, return the levels briefly. Is that using this function? I feel like is it using it? No. Set the level or get the level. And set the level. Set the level, and what we're gonna do right now is actually to do what? Self, and then what I'm going to do right now is set the levels. So how can we do this? So I actually pass the level value. Okay. level. That's true. Level goes to size. Self dot level. Okay, goes to level. Okay, that's right. Level. Okay, it's not right. It's assigned differently. Like generally what I did. Sure. Wait, no problem. I'll do a split. Split. One did a split. Like he said, it was updated with splits. Sure. Okay. Updates when splits. Implement multi-level routing. Okay. So let's see. And then so we could possibly do something like yep. Multi-level routing, extend the routing table to address multi-level routing. Splits node should actually be routing, right? Let me see. Extend the routing table to multi-level routing. We should be routed. Yes. Explain routing table to handle multi-level routing. Okay. Let's see. Okay.